This is a video presentation for high voltage technology subject, which is for the lab 4 DC high voltage measurement and monitoring. There is a 3 section 1, 2 and 3 that will explain later. My name is Muhammad Nur Afiq bin Hasni, and my other members is Syed Muhammad Hanif bin Said Baharuddin and Muhammad Hafizul Hisham bin Muhammad Zain. So for the first section, it will start with Hafizul Hisham.
Right now, I will explain about the section 3, which is construction of parallel DC high voltage measurement using FC and picoscope. As we all know, before this lab 3, we using construction of parallel AC high voltage. For this high voltage, there is a little comparison, which is before this we are using capacitor divider, and for this construction we are using resistive divider. So for the first FC panel is connecting to the high voltage transformer. Then they are connected to the 3 connecting cup, which is this is the diode. It may operate the rectifier. Then we have the 2 secondary part, which is this is for the AC, and another one is for the DC. For the AC, as you all know, the rated of the measurement is 2 microfarad for the AC. For the DC secondary part, the rated is 14 kilo ohm. Next, these are some suggestions for safety rules that need to be concerned at the adding switch and clean testing layout. First, the routing and connection of temporary wiring should be such that they are secure against accidental interruption that may create hazard to personnel or equipment. Second is device which rely on a solid or solid liquid dielectric for installation should preferably be grounded and short circuit when not in use. Third, any capacitive object which is not in use but may be in the influence of a DC electric field should have its exposed high voltage terminal ground. And the final is capacitive object having a solid dielectric should be short circuit after DC proof testing.
Okay, for this section 2, we have 3 parts, which is source control, primary side of transformer, second and secondary side of transformer, which is slot, and the last one is alarm system. Okay, for the source control, it has 3 scale of increments and decrements, which is the scale is 0.1, 1.0 and 10. For the primary side of the transformer, the function is to display the current and voltage output that has been measured. And then for the secondary part of transformer, we have 8 slot, which is V1 until V8, VM1 until VM8. For VM1, we use for AC measurement. For VM2 until VM8, we use to measure the peak value and the RMS value. Okay, and the last one is the alarm system. It's a security measure. For example, when the alarm system sounds or is active, we are not be able to perform any injection to the system. This is because our system is having problems or is there any security measure we forgot to do. Until this alarm system return to neutral, then only then we can do any injection to the system.
Assalamualaikum. So, my name is Muhammad Nur Afiq bin Hasni. So, I will continue this video presentation with explanation of section 3 and the conclusion of this laboratory experiment. So, for section 3, it requires us to construct the table comparison between the result of reference, which is from kit control, and display from picoscope. Next is to calculate the percentage of error between those value. Number 3 is we have to discuss about the discrepancy between reference and display based on calibration fact. And lastly, we need to come up with the conclusion for this lab exercise regarding to the experiment lab session. Okay, so next is a formula for percentage error. So this is a formula that we use to calculate the percentage error between reference value that we get from kit control and the display value from picoscope. For this lab, the measured value is from kit control and the true value is we get from the picoscope. Okay, next is about the table result. As we can see, the table result that has been constructed is uh, the value that we get is from mean value from both equipment, which is frequency converter and picoscope. It is from frequency converter we get for the reference, and the display value we get from the picoscope value. We can see from the percentage error that there are not so much different between those reading. The picoscope itself can capture and trace the signal with high resolution with uncluttered waveform. At some reading, we can see the percentage error that has been calculated were less and near to 0%. And even some of them has a minus reading on the percentage error. So this of course because of the surrounding of the experimental setup that can affect the reading, and also because the increasing of temperature surrounding can decrease the sensitivity of the equipment itself. The accuracy of the graph produced also on the picoscope will depend on the sampling interval that we said earlier. It's same as lab 3 for AC high voltage, which is 10 microsampling intervals. And for the coupling for this lab experiment, we set to DC because this experiment is required us to determine the DC voltage generation. So for the last one is a conclusion. For the conclusion, in section 1, we were able to construct a parallel DC high voltage measurement that using kit control and picoscope and the other suitable apparatus that we use. And after that, we were exposed and familiarized with these two high voltage equipment setting. And for the last one is we can compare and analyze the value obtained in the result. As we can see in section 3, we also be taught from the doctor's degree that many precautions to be measured that need to be held on conducting this experiment. It is because this experiment is related to high voltage parameter that can harm us and to protect our from hazardous action. and to perform our safety for this lab. Thank you.